In the last screencast, we normalized a particular probability distribution, and now we're going to use it to calculate the average value. So let's say we want to calculate, on average, how far is Spider-Man from the treehouse. So we denote this average using these brackets. That just means the average value of R. And the reason we do this instead of an overbar is that a lot of times in physical chemistry we use the overbar for molar quantities, and so we're going to save this for, we'll use this instead for averages. Okay, so anytime you want to do an average for anything, you just take the thing you're going to average, and the way you do this is you integrate the probability distribution, and it has to be normalized, times the thing that you want to average, in this case just R, over all available space. So this is our volume element, and then we're going to average over all available space. So we'll plug in specifically what that means for our limits for integral in just a second. Okay, well, let's go ahead and plug in our specific probability distribution here. So the average value of R is going to be an integral where we're going to, and of course we have to integrate over 3 variables. And what do we have here? We have R naught over 2 pi, so that's our constant from normalizing, and it's R naught squared, times R to the -5th. So this is just the value of, this is just the distribution here, right? This is just P. And then we have to multiply that times our thing that we're averaging, in this case just R, and then we need our volume element, and let's go ahead and use spherical coordinates again. So we've got d phi, a sine of theta, d theta, we've got an r squared dr, and I think I have not forgotten anything. Okay, good. So what we can do before we even start is we can start simplifying things. There's stuff that's constant that we can just pop outside the entire integral, so we could do that. Okay, so now we're going to combine all the R terms. So we've got our R to the -5th. We've got an R because we're averaging R, and then we have our R squared from our volume element. So we take a product of all those, we're going to end up with R to the -2 times dr. And our limits of integration, of course, normally R could go in spherical coordinates from 0 to infinity, but here we can't get any lower than R naught. We can't be as a number smaller than R naught because then we'd be inside this treehouse. So we got to start off at R naught, and we're going to go all the way out to infinity. Okay, great. Let's go ahead and take that integral. Okay, so let's go ahead and take the integral. So we said that the average value of R is equal to the results from this integral. So we've got our original constant from normalization. Take this, we can see that this is going to give us 2 pi. Take this integral, we can see it's just going to give us a value of 2. Let's take our time on this last one. We're integrating from R naught to infinity. So if we integrate R to the -2, it's going to give us R to the -1 divided by -1. So I'll put the negative out here. And let's go ahead and plug that in. Before we do it, we can cancel these 2 pi's, save us a little time. So we've got R naught squared times 2, and then we're plugging in infinity. Well, infinity to the -1, that's just going to give us a 0, minus, when we plug in R naught into -R naught over 1, so we've got -1 over R naught, so we can see those negatives are going to cancel, and so that's going to give us 2 times R naught squared, and then we're going to have a +1 over R naught. So we end up with the average value of R giving a very simple value, because we're able to cancel this with one of these to just give us 2 R naught. So the average value from the treehouse is just twice the radius of the treehouse.